And we're looking at aldehydes and ketones. Let's start with the preparation reaction. Let's see how we prepare them both. So you see, aldehydes and ketones are so easy because everything about them is just oxidation and reduction, okay? The reactions, how do you prepare aldehydes and ketones? Oxidation. You just do oxidize, 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 okay? You oxidize alcohols until you get aldehydes and both ketones, okay? So it's just oxidations that make these two. And then what about the reactions? Their reactions are oxidation of both of them. You know, we can't oxidize ketone to anything actually, but aldehydes we can oxidize it to a carboxylic acid, and then we'll do the reductions of both of them to back to alcohols, okay? It's just oxidation and reduction. Basically, these are the reactions of these guys. So what are the preparation reaction? It's oxidations, okay? Let's start with the first one, which is going to be, we can use, the first one is using PCC, okay? PCC, yes, it's an oxidizing agent. So this is oxidation. Remember, all of them are oxidation. So we can say oxidation by PCC, okay? And this is for aldehydes. So for aldehydes, we are going to use PCC and we are going to use Swan oxidation. These are two special ways to make aldehydes from primary alcohols. We want the primary alcohol to end at aldehyde stage. You don't want it to proceed to a carboxylic acid. So it's like you have, I'll put it like this, OH, and then here you have your whatever, something else, okay? So now what happens is if we add PCC, it's like we just oxidize using PCC, okay? And I know that you don't, this is pyridium chlorochromate. You can go and check the other video on it to see the structure of this guy. But the chlorochromate, the CC part, has oxygens there. So it's going to oxidize this guy. And simply what it does is it oxidizes this to be a double bond. So all you're going to have is this is now a double bond OR, and it removes one H from here. So this now just becomes an H and your R. So this is just what happens. And we can put this H down here if we want, or we can just put it as an H. So you see one H goes and then this OH becomes a double bond O, okay? But it doesn't change this H to an OH. If you don't use this, then this H will also then be changed to an OH, and you now have a carboxylic acid. But you wanted to keep it as an H. So this is what happens when you use PCC, okay? It makes your aldehyde. This is an aldehyde, okay? And this one was your primary alcohol, because you can see that this was the last carbon, okay, where your AH was, and it's going to give you an aldehyde, okay? The carbon which the OH is on is connected to one other carbon, okay? This is the one which we use. It's connected to one other carbon, so it makes it a primary carbon, okay? It's connected to one other, so it makes it a primary. It's the last one. Anyway, you can put any other thing. You can use other examples like this, and then you can put your PCC. We know that just becomes a double bond O, okay? So what you can do is you can put it like this. If you want to put it, here's your double bond O, then this is just an H, okay? It's just an H. All right, so this is what happens. You can put it like this if you want. Why did I put an H? So that you can show the double bond O on this carbon. That's all you have to do, and you are done. Now, the other one is number 2, is you can say oxidation. So we can just call it Swan oxidation, okay? We'll do Swan oxidation. It is a type of oxidation that was discovered by some guy called Swan. So now what are we going to do? Well, you're just going to use, it uses four things, and the temperature and the freezing temperature, you'll freeze it, okay? So you use DMSO, okay? And each represents something. Dimethyl sulfoxide, okay? DMSO4 is dimethyl sulfoxide. Then you can use ET3N, which is triethyl amine. It's an amine. Remember, there's a nitrogen. So if it is bonded to like carbons, like two carbons here and some 2 carbons here again, then some 2 carbons here. So these are ethyl groups, okay? When you have 2 carbons, we say it's an ethyl. So this is triethyl amine. And what else are you going to have? You're going to have this guy, COCl2. You put the 2 outside, and this is oxalyl chloride, okay? Then the last and fourth one is going to be CH2Cl2, which is just like a carbon. You put 2 chlorines, okay? Then you put 2 hydrogens, okay? Which is dichloromethane. This is dichloromethane. So these are the 4 things. DMSO, ET3N, which is triethyl amine. Then this is oxalyl amine. So this is oxalyl chloride, okay, COCl2. Then this is going to be dichloromethane. This is nice. So you use these 4 things, and you use a temperature of negative 60 degrees Celsius, like a freezing temperature, and you can be able to convert any primary alcohol to to what is it? To an aldehyde. So it's like you'll be having your primary alcohol, whatever primary alcohol you want to have. Choice is yours. Okay, you can have the OH here, and you can put those four things again: DMSO, dimethyl sulfoxide, triethylamine, then oxalyl chloride, COCl. You put the two outside of a bracket. Then you can put these two outside to say COCl2. No, you put the two outside. Then you're going to say plus, you're going to have another one, which is CH2Cl2. Then you also put the temperature, which is going to be negative 60 degrees Celsius. Okay, then what are you going to get? Of course, you're just going to get an aldehyde, where this just becomes a double bond O. So it's just going to be like this. So it's just going to be like this. This carbon, which is carbon number 3, is where you're going to put the double bond, and you change this to an H, okay? This OH, you put it here, okay? That's what happens because it's on carbon number 3. That's what happens, and you are done, okay? This is converting to an aldehyde. Then now for ketone, it's so easy because for ketone, it's just, okay, this was Swan oxidation is for aldehyde again. And the last thing which you have to do is just for ketone. For ketone, we can still use these two, Swan oxidation and PCC. We can still use them to be now, you'll be now having a secondary alcohol where the OH is inside. It's not on the last carbon, okay? And whatever you use, but we like to use KMNO4, okay? So you can still say oxidation using either. We like to use very strong oxidizing agents, like, because they are faster, okay? KMNO4 or K2CR2O7, okay? And this, we know it is for ketones, okay? It is for ketones. No more aldehydes now. This is for ketones. And what are you going to have? You just have a ketone. Well, how do you have a ketone? It's still just going to be a double bond O. That's all that happens. That's all that happens. So this just becomes a double bond O. That's the only thing that happens, and you'll be done. This is your ketone, okay? And you just count 1, 2, 3, 4. This was butanol, okay? 2 butanol. And here it's just going to be 2 butanon. And that's just it, okay? These are the oxidations for aldehydes and ketones, and you are done. That's how you make them, okay? Now we're going to the next thing.